Hello, welcome to day 3 of math distance learning. Let's go through your entry task. Hopefully you have had a crack at all those problems, and I'm just going to walk you through answers and you can check yourself. So problem 1 was the number 14,700, and you were supposed to write it in scientific notation. I'm going to try and turn this and see if I can get this the right way. Sorry about that. And so if you remember from yesterday when we talked, scientific notation means that you are writing a number in between 1 and less than 10, and then times 10 to a certain power. So in this case, I'm going to move the decimal point to right here, and I'm going to write 1.47 times 10. And then we have to figure out, to get 1.47 to turn back into 14,700, we would have to multiply by 10. 1, 2, 3, 4 times. So it would be times 10 to the 4th power. Question 2, so maybe I'll just write that over here on the side. 1.47 times 10 to the 4th. Question 2 was 0.00083. And so in this case, because we know it's a very small number, we're going to have 10 to a negative power. So again, we want to turn this 8 and 3 into a number between 1 and 10. So I'm going to make that 8.3 times 10. And to get from 8.3 back out to this, we would have to divide by 10 1, 2, 3, 4 times. So it would be times 10 to the negative 4th power. Don't forget that negative sign. So number 2 is 8.3 times 10 to the negative 4th power. Number 3 was 760 million. So again, back to a large number, so I know that times 10 will be to a positive power. So for this one, that's 7 and 6. Remember, for proper scientific notation, I can't write 76. I have to write 7.6 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8th power. It's these 7 zeros plus that 6, which makes it the 8th power. So number 3 is 7.6 times 10 to the 8th. Number 4 is 0.038. And so to turn that into a number in scientific notation, I would put that decimal point behind the 3. So I'd make it 3.8. And it's a very small number, so to turn 3.8 into this 38 thousandths, we'd have to divide by 10 twice. So it would be times 10 to the negative 2nd power. So number 4 is 3.8 times 10 to the negative 2nd power. Number 5 was just the number, 0.38. And so this one is actually pretty close to already being in the proper form, but you just have to, because this is not a number in between 0, or in between 1 and 10, you'd have to change it into 3.8. And so in order to get it back to 0.38, we'd have to multiply it by 10 to the negative 1st, or in other words, divide it by 10 one time. So number 5 is 3.8 times 10 to the negative 1st. The next one is kind of a trick question in a little ways. It's saying the number 3.8. Well, this number already is kind of in proper scientific notation, but really for scientific notation, you would just add on a times 10 to the 0 power. Because if you remember, anything to the 0 power is equal to 1, so that's like saying 3.8 times 1. And for scientific notation, you do need that times 10 to some power. So it's 3.8 times 10 to the 0 power. Number 7 was the number, let's see, what is that? Hundreds, thousands, millions, billions, trillions. 3,800 billion. Very large number. And for this particular number, we would put the decimal point in between that 3 and that 8 again. So it's our fourth one in a row where 3.8 is that first number. And then it would be times 10 to the 369, 9th power. So number 7 is 3.8 times 10 to the 9th power. And then there was one more like this, which was a very small number. It was the number that was a 0 point, and then there were 9 zeros, and then the number 9. And so to make this into scientific notation, I'm just going to have 9 times 10 to the, well, to get the decimal point from here to here, I had to move, so from here to here, I had to move over 10 spaces. So it's to the negative 10th power. So number 8 is 9 times 10 to the negative 10th power. If you've got any questions about any of these, please post them on that discussion board, and I will know to check in on that, and I can try and answer those questions for you. So then there were also 3 more questions that were part of your entry task, and those 3 questions were just checking in again on your exponent rules. And so I'll really quickly just go through the answers on that so you can check yourself. The first one was 10 to the 4th power times 10 to the 6th power. Now, if you remember using our exponent rules, we're multiplying 2 numbers that have the same base. So we really can just add the powers, and that becomes 10 to the 10th power. The next one was 10 to the 12th power divided by 10 to the, I believe that's a 3rd power. And for that one, we're using our division rule, so really we can just subtract the powers. So 12 minus 3 is 9. So we have 10 to the 9th power. So this was number 1, this was number 2. And then for the third one, it was a little more complicated. We had a 4 times 10 to the 3rd power times 8 times 10 to the 5th power. And remember, if this is all multiplication, I can just kind of rearrange things. So I can make this say 4 times 8 times 10 to the 3rd times 10 to the 5th. And if I simplify that, 4 times 8 I know is 32. 10 to the 3rd times 10 to the 5th I know is 10 to the 8th. So I would probably leave my number like this as 32 times 10 to the 8th. Or if you want to put it in proper scientific notation, you could write 3.2 times 10 to the 9th. Thanks. Go back to Schoology and keep working on, watch the next video actually. There'll be another video up there with some instruction for today, and then a problem set for today for you to submit at the end. Happy mathing!